Assalamualaikum warahmatullahi ta'ala wabarakatuh. How's everybody? Okay. All right. First, I want to discuss about the test. I inform you, we will discuss about the test today. We're going to set the date. I propose Monday the 20th, not Monday, next week. Monday the other week, the 20th of November. So I want to see, is there anybody having a class on Monday? Now, I want to do it at night because I have three sections. Okay, the other class is section 11. So we need to do it at the same time. So therefore, we have to meet, or we have to do the test during the night. So I suggest Monday. I hope nobody has a class at night. Monday. Monday the 20th. 20th, is it too late, 20th? Or you want it next week? Do you want it next week or the other week?
The other week.
Okay. Okay. 20th, 11, 21. Now we're going to do it at 8 p.m. Anybody has a class during the night? I don't think so. Okay, if you have a class during the night, that means make an excuse. We make it after Maghrib. Now Maghrib now is quite early. All right, 7 o'clock already Maghrib. So we don't want it to be too late. If I make it 9 o'clock, it's too late already. So 8 o'clock will be enough. Okay, will be enough. Will be nice. So 8 p.m. That will I give you 1.5 hours. So that will be up to 9:30 p.m. Okay, and then plus 10 minutes to submit. Okay. So like I said earlier, coverage is only up to the things that we learn on Monday. So coverage we will be up only to here. All right. So the things that we're going to learn this week and next week, that will not be in the test. Okay. All right. Any other things? Any question or anything that you want to discuss about? Okay. All right. So what I will do today, I'm going to move on to the next topic. Now, next topic is on the partial derivative. Partial derivative. Derivative chapter berapa look at the book. This is chapter number 14. Oh yeah, number 14. So we are going to chapter number 14. So the title of the chapter is a function with more than two variables, two or more variables. So here, okay, this is we have 14. Where they want to do is partial derivative. Okay. Now, in order to do partial derivative, we have to know about the function. So here we are going to look at a function general form. Okay. General form. of a multivariate function. We call it multivariate function because there are more than two variables, multivariate function. In the form, I have y as a function of x1, x2, up to xn, where y is the dependent variable. And then the x's, okay, x1 up to xn, the independent variable. I from 1 up to n, okay, they are integers. Okay, integers, meaning that be 1, 2, 3, 1, 2, 3, and so on up to n. So this is what you call the general form of a multivariate function. Now for us, let's give you an example. First, we come up, I'll give you the second example. Example, let's say n equal to 3. For an n equal to 3, what we have will be y is a function of x1, x2, x3. So there are 3 independent variables, x1, x2, x3. And the dependent variable is y. If n equal to 2, then you have y is a function of x1 and x2. So there are 2 independent variables, x1 and x2. Now for us, right now we are talking about us. Our focus will be this type of function, n equal to 2. We call it three-dimensional function, you know. You have 2 independent variables and then 1 dependent variable. Y is a function of x1 and x2. Now, if in this case you have 2 independent variables, the normal practice is instead of writing it y in terms of x1 and x2, we can use other notation. We use z instead of y, and then it's the function of x1 and y. So we just relabel the variables. So that's just for the, for the 2 dependent variables. You have x, y are the independent variables. And then the z, or z is dependent variable. Okay, so for the 3 variable case, where you have 2 independent variables, the common practice is, if you look at the book, we write in terms of z as a function of x and y. So we call this 3-dimensional function, okay, or function with 2 independent variables. So if you look at example, go to example number 1, example number 2, example number 3. So let me show you the picture in the book. Senang sekali ada tengok apa. You have this kind of thing. Kita nak bukti itu juga. So tadi saya record lagi. Ada. Chapter number 14.
Ini kemarin bolongan itu aja buka.
You have dependent variables. Z is a dependent variable. Example, macam ni. Alright, you have an example, x squared minus 3y divided by x. That's why this is example number 1. Okay, don't worry about the domain. We didn't discuss from the perspective of the domain. So don't worry. Just worry about the function. Okay, that's an example. And then another example. Yeah, example lagi. Okay, another example would be like this. You have z equal to 4 minus x squared. Ni y squared ni. Bukan x squared. Right? 4 minus x squared minus y squared. Dia tu, gambar dia tu. Okay, so I think there's a typo there. It should be z equal to 4 minus x squared minus y squared. It's a function of x and y. So these are a few examples. You have 2 independent variables. Now next, how do we draw the graph of this thing? Okay, you draw a graph. When you draw a graph, you end up with a 3-dimensional graph. So if we recall, you should recall, for the y as a function of x, you have the graph x, y. So that is what? Y function of x. Now, when you have 2 independent variables, you have z as a function of x and y. Now, this x and y are the independent variables. Y now, okay, becomes independent variable. So these two variables, x and y, are the independent variables. That means the axis, horizontal axis, vertical axis, they have become the independent variables. So where is the dependent variable? Z. The Z will go, okay, you imagine, all right? Imagine you have a floor, okay? Imagine this is the floor of your house. The Z, the X is the wall going one side, all right? Let's say to the north or to the south or to the east, to the west, doesn't matter. Say X is one side, Y is the one that is perpendicular to it, the other side. So if this is east, okay, suppose that is the east side, Y ni north lah. Okay, no. This is west, that is south. Okay, no. Now the dependent variable, the axis of the dependent variable Z is the one that goes up at the bucu, okay, at the bucu of your wall, at the corner of the wall where X meet Y. So you go up, okay? So imagine that thing, the line goes up, all right? That will be the X, the Z axis. Go up, okay, go up. This only go up. Okay, I put a dot here, that is going up. Okay, going up to the sky. So that is our Z axis. So what you end up would be 3-dimensional graph. Okay, 3-dimensional graph. And then when you have 3-dimensional graph, your graph will no more be a line. Okay, line is where you have X and Y. But now our line, okay, the graph of the function would give you object. Okay, object. It's not just a line, object, 3-dimensional object. So 3-dimensional object. Macam manusia, okay, we are 3-dimensional. Everything on Earth, you know, that has proper width, height, and length is a proper object. All right. So you have an object. Now, how do you draw the graph on your paper, on the sheet? So in order to draw the graph, this is how you draw the graph. So you look at the book. look at the book, the example they show you here. Tidak. So what you do, all right, what you do, from the one that I draw just now, okay, begini, we reposition it so that you can draw it on a piece of paper or on the screen. So what you do, you make the X horizontal, sengit ke sikit, slanting like that, okay, and then next you do the Y horizontal as well, straight, okay, straight from west to east. So that is our Y. Okay, that's our Y. And then you can show the Z going up vertically. So that is how we draw the graph. I think maybe some of us have seen graph like this. So we label the flat axis. Okay, this one is X, the one is Y, and then the one goes up will be Z. So the origin is 0 there. Okay, that's 0. Apa ni dia tak label 0. Okay, we should label that 0 there. Okay. Cukup, eh? Are you clear? All right. So will be like this. You realign the things. I have X going this way. I'll draw it full screen. Macam tu. Okay. X. Okay. And Y, we just make it straight gitu. Now, that gap, okay, that gap is 90 degrees. So you label 90 degrees. Okay, so it's 90 degrees. All right, everything will be 90 degrees. And then where the lines meet, so that is our origin, 0. So from there, so that is our dependent variable. So you have X, Y, Z. And that is how we draw the graph. Now, like I said, the front side, okay, the front side, that is the wall for the X, okay, the bottom of the wall for the X. That is the bottom of the wall for the Y, okay, and that is the border XY, okay, that corner. So the corner of the walls XY, you get Z. So this is your room. So we call it the front side. Okay, that's your room, okay, the front. And the other side is the one that is behind your wall, all right? Behind your wall, you cannot see, okay? So for the sides that we cannot see, we make it broken line. Imagine this wall, okay? X, one wall, Y, one wall, Z, different border. So you cannot see behind the wall. So the other part, you make it broken line. We call it the negative values, okay? And this is under your room or below the front axis. So this is our, like the front side, okay? Or the positive part. That is the positive part. The first quadrant. So we label the values, okay, just like graph, every graph that you have. Let's say we use interval of 10. So that is 10, 20, and so on. Now to the other side, the one that we cannot see, okay, that is negative 10, negative value. Okay, now similarly for Y, sorry, for x. For x, that would be 10, 20. And the other side, negative 10, negative 20. Okay, you go up, that is the z, 10, 20. Bawah ni bawah, ni dalam tanah ni, negative. Okay, so that's how you label the graph. Okay, all right. So what you want to do next is that I have a function y as a function, z as a function of x and y. Now you want to describe a point, okay, a point on the graph. Okay, let's see. Let's see, do they have it on the notes? Point, locate a point. Macam ni locate point. So you have the 3 axes already, okay, and you have the graph. So now you want to locate a point. So how you write a point, macam ni lah, x, y, z, for any point P. So x to first value independent variable, y, the second value, the independent variable, second. And then the dependent variable will come last, z. Okay, so a point on the graph, we just call it x, y, z for any point. Okay, so I go back to my graph. That means any point on the graph, let's say here, okay, that's 1 point. So how do you label it? X, y, z. Okay, that's one graph. Okay, like that. Right? Okay, so if you have an example, say, ni dia bagi example. Example is point 2, 3, 4. How do you locate point, as an example, 2, 3, 4? How do you do that? So the graph, they already put the point. Okay, that's the point. Okay, that's the point 2, 4. Now, how do you locate point 2, 3, 4? Okay, this is how. Firstly, all right, you just consider x, y. Okay, so firstly, to locate a point, okay, locate a point, number 1, kata x, y, z lah. First one, what do? You just locate x, y. So x, y will be what? The axis x and y. All right, the axis x and y. So that will be the floor. X and y. So x is, x is 2, y is 3. So x2, y3. Ini lah dia. X equal to 2, y 3. Okay, so you got that point. X equal to 2, y equal to 3. I got that point. Okay, that's the point on the flat surface, on the floor. So that is x, y, 2 and 3. Now from there, you go or you determine the value of y. Okay, so the value of y is 4. So where is the position? Now you go back to your graph. 4 will be up there. Okay, because it's positive. Therefore, so you go to the 4, that is 4. All right. So now when you have 3-dimensional object, you see here they don't put 4 up there. Of course, it's very subjective depending on how you draw it. So they put up 4 here. Maknanya you have to go down macam ni lah. Okay, so that is 4. So the point 2, 3, 4 will be there. All right, but the method is, firstly, you locate x, y. After that, you will determine the corresponding position of the z. Number two, after you got xy, then you locate, okay, locate with the y, the z, I'm sorry, whatever it is. All right, so that's how you draw it. I'll give you another example. Let's say example number two. Since I have your, I have your, the scale of my graph is 2020, 10, 20. So let's say I want to locate a point. I think I will, next page. I want to put it 20, no, 30, 20, 40. 20, 40. Okay. I want you to go back to the graph, locate that point. 30, 20, 40. First, you do it on the XY axis and then get the value of the Z. Okay, first you do that one. Okay, so use the flat space. Okay, use the flat, the first part of the graph, XY. And then to determine the value of Z, do you go up or you go down? You go up because it's a 40, all right? So the point, where is the point? I show you my graph. The point is where? Where is the point? You got the point? 30, okay? X is 30, it will be somewhere here. So I got to add, ini 30 kat sini. Okay, 30, 20, 20 there, 30 there. So roughly about here. Okay, that's XY. Now the value of the Z is 40. So 40, kita tambah 30. All right, so let's say 40 dekat situ. Okay, 40. So you go up. We go up 40. Sampai. So kita, because of the nature of the surface, you know, that will be somewhere there. So that is the point. 30, 20, 40. Right. I give you another example. Locate the point negative 10, 30, 20. Okay, I give you more. 20, 30, negative 40. Okay, look at these 2 points. So first you got XY and then you get the value of the Z. Okay, I give you 2 minutes. The first person who get it, let me know so that we can proceed. Okay, you got the first point. Negative 10, 30, 20. You got it? Okay, where is that point? Okay, you got the first point? Somebody who get the first point, let me know. Okay, where is the first point? I'll go back to the graph. I have negative 10, 30, 20. Okay, 20, 30. Everybody got it? All right, good. So now what we want to do, we already know how to locate a point. So that's how we do how to locate a point. And then I give you already a few examples of a function. One example where you can see the graph of the function, this one. As I said earlier, the function, when you draw the graph, will be like an object. So example here, this is example number, if you look at the book, that is example number 2. Is that to be okay. So you have the picture given in the book. It's an object. So here, the object looks like a dome, okay? Not actually a dome like our dome. It's a very steep dome. That object. So it can be spherical, okay? It can be cylindrical. It can be hexagonal, all right? Whatever object, it's an object. So that is one example. Very, very nice picture. Okay? So that is one example. So that's how the graph look like. Now what I want to do next is that given these functions, we want to do the derivative. Okay, you want to take derivative of the dependent variable with respect to the independent variable. So that's where we come up with the partial derivative. All right. So here, you can see what you want to do. You want to find the derivative of the function. Okay, z as a function of x and y. It's a multivariate function. When you do the derivative, we call the derivative partial derivative. Okay, why is partial? Because there are more than one independent variables. Now, when you do the derivative, we do the derivative with respect to one independent variable at a time. All right? So that's why you call it partial, because there are more than one independent variables. Let's say there are two. When you do the derivative, you do the derivative of the dependent variable, z, with respect to one variable at a time. So that's why you call it partial. And the first derivative, we call it first derivative, or you don't have to put the first order. You call it first partial derivative. Okay. So I think the other part too, I think I'm going to down. Okay, I think I'm going to read you right, right? So you have z as a function of x and y. Take the derivative of z with respect to x. Okay. Now, when you take derivative of z with respect to f, what do you do to the other variable y? You consider the variable y as a constant. Okay, variable y, we treat it as constant. We think of it as a constant. It's not a constant, all right? But when you take the derivative of the z with respect to x, treat it as a constant, the y, okay? So the derivative of z with respect to x is the partial derivative of z with respect to x. So how do you denote it? You denote it by dz dx. Now the difference will be what? The d though. Okay, you don't use d, you use the d, the Greek d, the corner. Okay, dz, but still we call it dz dx. So that is dz. Now, when you take the derivative of the function z with respect to y, okay, now the other variable you consider a constant, that is x. So x, you consider it as a constant or think of it as a constant. So you take the derivative of z with respect to y. Now we denote it as dz dy. Okay, dz dy. With the Greek d. So this is the basic notation. Okay, the basic notation for the partial derivative of z. Okay. Okay, you write down. Okay. What I said, you read here, you write down your own. Okay, make note. If you think tak faham, unless you are very good. Okay. I know some people are very good, but many of us, we are not good. So you have to do the work. Okay, write it down. Okay. All right. So this is the partial derivative. Okay, paham? All right. So if you have the function, consider a function that equal to f of x, y, right? Now, number one, you take the derivative with respect to x. So we call it dz dx. So partial, we can have the second partial. So we call it first partial derivative lah. We just sometimes we just call it first partial. Number one, a dz dx. That is how you write it. Now there are more than one notation. We can also write it as zx, or we can write it as fx. So for us, the simplest way to write, okay, because fx, and it come up with the function. So you got fx. Now this x, don't write the fx, it's not multiplication, okay? It's not fx as one word. The x must be the subscript, okay? Bawah tu, subscript, yeah. Subscript. So when you take derivative with respect to x, we treat, okay? You keep y constant. So that's why you call it partial. Okay. Now, second, I can take the derivative of the function with respect to y. We write dz dy, zy, or fy. Now, which variable do you keep constant? X now is a constant. Just keep, okay, or consider. They are not constant. Okay, they are variables. But when you do the process, we think of it as constant. Okay? So that is the basic idea of partial derivative. Okay, any question, anything? Okay, good. So now we are going to consider a few examples. You look at the book. Okay, look at the book. Example, let's consider example. Okay, the example. Okay, the question. So let's consider an example. Okay. I think the example will be in 4.2. Okay, the partial derivative is in 4.2. So go to 4.2. All right, 4.2, they have the things. So 4.2. So 4.2, you have the notations, and then they give you the examples. We look, for example, yeah, boleh bagi ini susah. Now, okay. Okay, we look at that example afterwards. Okay, I will give you simple example. Okay, suppose you have the following. Okay. Example. Okay, before that. Now, when you treat the other variable as a constant, so let's say I take derivative with respect to x, y is a constant, okay? I take derivative of z with respect to y, x is a constant. So you follow the rule, okay? When you keep the y constant, x a constant, we follow the constant rule, okay? The derivative, how do you treat constant in the process of derivative? So the rules, okay, the rules of the derivative that we learned earlier will apply. You don't need any new rules. All right, you don't need any new rules. The existing rules are sufficient. That just now, what we do is we treat the other variable as a constant. I'll give you an example. Okay, this is example number 1. All right, I have z as a function of x and y. Suppose I have 100 plus 2x squared minus 5y to the power of 4. Okay, I want you to find number 1, fx, the partial derivative of the function with respect to x, and then partial derivative with respect to y. Okay, I want everybody to try. When you take derivative with respect to x, y is a constant. When you take derivative with respect to y, x, constant. Okay, now, I give you 2 minutes. You try, okay? Try to do it. So nobody see your answer. Doesn't matter whether it's wrong or it's right. I want everybody try. Okay? Kalau tak tahu, hentam. Okay, got it? All right. Now, when we do the derivative, like I said, we consider the other variable constant. So fx, derivative of the function with respect to x. Okay, so y constant, right? So now that y is a constant. So this is a constant. So you imagine y, you know, macam number say 5 or 10 sebab 5 dah ada. So you imagine it's a number 10. All right? Okay, first 100. 100 memang constant lah. So the derivative is 0. So don't worry about that. And then x is the variable because you are taking derivative with respect to the x. So I got 4x. All right. Now, problem is now that you have the variable y. So we take it as a constant. Okay. So if I differentiate 5, okay, 5 ni tak benda lah. 5 is a constant already. But this is also a constant. So what is the derivative of a constant?
Zero.
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 Okay, so that is a 0. So that is just equal to 4x. All right, so you imagine if I put 10 here, imagine 50. Okay, you're not right, but imagine 50. Okay, you imagine 50, so what? So I put here 10, because 5 is a constant. Okay, you have another constant, which is specifically y, so 0. Okay, and that 5 is just the coefficient of the y. But if you multiply that out, becomes 50 or whatever. It's 50 is not, it's just my example. You can think of it as like 10, whatever, the value. Or after you are familiar, you don't have to think. You know it's a constant. So that is, derivative is 0. So it's just 4x. Okay? Now, if you get it wrong, that's fine. Because this is new. Okay? I just want you to try. So that is constant. Okay? You treat y constant. Derivative of a constant here, 0. Okay? All right. So if I take the derivative with respect to y, okay, now the y is the variable. The constant is the x. Okay? So I may, okay, because I don't want to mess up over there. So I write down sekali. So 100 plus 2x squared minus 5y to the power of 4. So now, the constant is the x. Yeah, any constant? It's not a constant, but you treat as a constant. So you imagine, okay, kata 10 juga ni. Okay, imagine a number 10. So what is the derivative of 10? Or constant? What is it?
0.
0, okay? So 0. So you need 0, 0 plus 0. The only thing that you need to differentiate is the y, okay? So we know the rule. So we become negative. 5 times 4, that is 20, y to the power of 3. Because the 2x is 0 already. Okay. Anybody got it wrong? So that's okay. Okay, I give you another example. So example number 2. Now let's say I have z equal to 24 y to the power of negative 3 minus 10 x to the power of 1.5, 1.4 plus 96. Bukan sama je macam tadi. Okay. So now take the derivative fx, then f. Okay, do it now. Okay, right? So what is the derivative? Okay, take derivative with respect to x, y constant. So now you know y is a constant. The derivative of a constant is 0. So don't worry about that. 0, the only variable is x. So you've got negative 10 multiplied by 1.4. Reduce the power by 1. So 1.4 minus 1, that would be 0.4. Plus derivative of 96. 96 is a clear constant, so 0. Okay, so that is the derivative. Now fy. When you take derivative with respect to y, what is constant? X constant. So that is a constant. So don't worry about it. Constant. Derivative of a constant is 0. 96, 0. So we worry about the term, the first term. So I got 24 multiplied by negative 3 times y, reduce the power by 1, that is negative 4. Okay? All right. Any question? Okay, now the examples that I give you, example 1 and 2. You see here, the x and y, they are additives. Okay. I have, if you look at this example, I have ax to the power of n plus by to the power of m. You see, they are additive each other. Okay. Now there is another form of functions. If you look at the book, they give you example number 1. Okay, I want you to look at example number 1 in the book. So if you look at example number 1 in the book, you will see, now this is in book. Okay, look at example 1 saya. Example in the book. What can you say about the function? You have x and y are additives, but there is one term, the second term. What do you call that term? What do you have that? It's not additive. It's not just addition of x and y. What are they? What is it? You have what? You have the multiplicative terms. All right. So if you look at the example, I have a one term here. 5 multiplied by x squared multiplied by y squared. Now the rules are the same. Okay, the rules are the same. That means if I take derivative with respect to x, the y will be a constant. Okay, so you just apply the coefficient rule. Okay, the power rule or whatever rule, and that constant, the variable that you treat constant, will just be the coefficient of that variable that you want to take derivative with respect to. Okay, all right. So that is the problem. Okay, this one where you have the multiplicative. So you think of the other variable as coefficient. Okay, constant coefficient of the variable. So when you take derivative with respect to y, x is the coefficient. If I want to take the derivative with respect to x, okay, then y is the coefficient. Okay, all right. So I give you an example. Example number 3. The example 2. Okay, let's say we have z. Z is equal to negative 2.5 x to the power of negative. We'll put negative 10 y to the power of 31. Okay, plus. I think we make it simple, but plus 104 x to the power of negative 9 plus 6y to the power of 3. Okay. Okay, the one that we already are familiar with, okay, once you're busy. But the things that is new, like I said here, multiplicative terms, x and y, all right? So like I said, when you do the derivative of with respect to one variable, the other variable is constant, treat it as coefficient. Okay, I want you to try. You got it wrong, it's okay. Okay, afterward, I will discuss so that we know where you got it wrong. Okay, I want you to take the derivative with respect to x, fx, take derivative with respect to y, f. Okay, now I'll give you 2 minutes. Okay, right? Okay, kita buat yang senang dulu. Okay, the one that you already know. So first, the second term, so I put the sign here lah. Okay, kita buat. So the second term is x, all right? So I got 104 multiplied by -9. I reduce the power by 1, so that becomes -10. That y is a constant, so 0. I don't have to write. Okay, now, this is the thing. That's the term. Now, when you take the derivative with respect to x, so I just write down here, okay, 2.5, x to the power of 10, y to the power of 31. So that y to the power of 31 is a constant. Okay, it's a constant. But now that constant is multiplied to the x. That's like 2.5. So that you consider it as a coefficient. So what you can do, since it becomes a coefficient, okay, you can do it, or you can, what we can do, I put it together. So I got 2.5, I multiply by y to the power of 31. So that two terms are the coefficient of the x. So you got x to the power of 10. So that y is the coefficient, okay? Ini coefficient ni. Now you can imagine number, okay? Number, don't worry about the power, okay? Constant multiplied by power 1000, still a constant. So imagine number, suppose you imagine number 10, 10. Imagine 10, but don't write 10, okay? Imagine it's a 10, it's a constant. So that is the whole thing as a constant. So the constant, you apply the constant with the power rule. Okay, you know that rule already. So we only worry about x to the power of 10. What is the derivative of x to the power of 10? So I put around here, okay, 2.5 y to the power of 31. So that is the coefficient. So you take derivative with respect to x. So I got 10 x to the power of 9. Okay, anybody got wrong? If you got it wrong, that's good. Okay, as long as you do it. So now you check back your answer. By now, we should know what is the mistake. All right. What is the mistake that we overlook? Okay, any question about this? No, I want you to make sure you understand this, all right? Afterwards, I'll give you a practice question. But before we move on, anybody has a problem, let me know. Okay, you can talk now, okay? Anybody has a problem, say it out so that I will go through one more time.
Sir, we
Yes.
don't take the 2.5 in the front.
The 2.5. Why you don't take?
No, I ask you. We don't take for x because the derivative x. So we don't take 2.5. So we don't need to take 2.5. Right?
We take 2.5. 2.5 is still there. Okay. 2.5 here is there.
So for the x power of 10, only that.
So when you put the coefficient, the constant, now there are two constants, right? 2.5 y. So you don't have to multiply 2.5 to the x because it's already multiplied. 2.5 y cubed is already multiplied to x to the power of 10. Okay, so that now the 2.5 multiplied by y to the power of 31, the whole thing here is the constant. The whole thing, 2.5 multiplied by y to the power of 31 is the coefficient of x. Okay, the coefficient of x. Now dua-dua ni, the whole thing here now become what? Become constant. Okay, so you don't have to multiply lagi dah 25 dengan x. Okay, you don't have to multiply x power of 10 lagi. Okay, you don't need that because I already put it there. Okay, unless you do this, unless you put y31, okay, and then you put 2.5. Okay, 2.5 x to the power of 10. Ya tu boleh lah. It's okay too. All right. Is that what you mean?
Yes, sir.
So you can do that. Boleh juga. Okay. But the simpler way is you just put together the constant. Okay. Put together the constants, and those constants would be coefficient of the x. Okay. So you don't have to do this. But if you want to do this, okay, and think of it as a constant. So you take derivative, you will get the same thing. Okay. So yeah, okay, you can do that. All right. Okay, good. So you have your 10. You can multiply by the 2.5. Okay, you can multiply by the 2.5. So that means you have to write another step now. 10 multiplied by 2.5, and then I have 104 multiplied to -9. So you can write another step to simplify the numbers, right? But if you don't, okay, just like that, because what you want is to get the derivative. Okay, all right, any other thing? Any other question, any other comment? Okay, all right. Now we look at f of y, fy. So if you did a mistake, fx, so now by now, okay, you already get the method. So if you think that your fy is wrong, okay, now you can modify. Okay, modify. So when you do the fy, the x would be constant. The constant. So if you got it wrong, give you a few minutes to look at your solution, your derivative. You can make the correction. Okay, all right. So when you do the derivative with respect to y, now the constant is the x to the power of 10. I have y to the power of 31. All right. And then, of course, I have another term in y. So we do the first term, the third term, okay, it's easy. But when, after we understand this, then we can start as it is now. So Fy, you do the second term, because it's only, you have Y. So I add, okay, 6 times 3, 18. Because small number, you can multiply right away, Y squared. The other term, x to the power of -9 is a constant, so 0, all right? So the only thing here is that one, okay? 2.5, x to the power of 10, y to the power of 31. So the variable here now is that y. So what do we do? Like I said earlier, x is a constant. So what you can do, okay, you put the constant together so that we will not be confused. So that is a constant now. The x to the power of 10 is a constant. So ini dah constant lah, okay? You imagine it as a number 20, 5, or whatever. And the only variable is what? Y to the power of 31. So yeah, you have to differentiate. You know the rule, the constant will just follow the derivative. Don't worry about the 2.5x power of 10 because they are constant. All right. So what is the derivative of the y to the power of 31? We know already, but you have to multiply by the constant. Okay, the constant will just follow. Don't throw away that constant. So now I have 2.5 x to the power of 10. And then I got 31 y to the power of 30. Okay, right. So that is the answer. Now, one common mistake that people do when you have this kind of terms, they will throw away that constant function or the variable that you do a constant. One common mistake, you throw that away. I show you an example. So when you do the f of x, then what you have will be just 2.5 multiplied by 10 x to the power of 9 plus, okay, plus the second term. So what you do here, that y, 31, though, hilang, okay, lost. I don't know where. So that is wrong, okay? Don't throw away that variable which you treat as a constant. And similarly for the fy, when you do the fy, what people tend to do, you got 2.5, then you got multiplied by 31, and then y to the power of 30. So that x to the power of 10 lost. So it's wrong. Okay. So if you do that mistake, I'm sure some of you do this. Okay. So now you treat it as a constant. Okay. You treat the variable as a constant. Don't throw it away. Okay. You just treat it like 2.5. So the constant you have, you can put it together. Okay. Put it together so that will not be confused. When we are good already, then you don't have to do like what I'm doing now. Okay, you can just do the derivative straight away. Okay, I'll give you another example. Okay, I'll give you another example. Okay, I want you to do question number 3. The second example, we try question 3. Okay, for 14.2, question number 3. Okay, right. So you have a multiplicative term. Okay, you got it? Okay, good. What did you get? Question number? Question number 3, yeah? Okay. So fx. Okay, fx, your first term is x cubed. Okay, so x cubed, that will be 3x squared. Now the third term, you got 6y squared, so that is your 0. The only issue is the 4x squared times y. All right, so what you do, okay, what you do, you put that y together with the 4. So that will be our constant, the coefficient. Multiply to x squared. Don't worry about this, that's a constant, okay? So what do I get? I get plus 4y, okay? You can put bracket, times 2. So you can multiply 4 times 2 times 8y. Okay? All right. Now, what about fy? You have 6y squared. Okay, the x cubed, of course, that will be constant, so that is a 0. So I just put that y first, so I got 12y. Now, same thing here. We have 4x squared, the 4x squared y. So that 4 and x squared will be the constant. Okay, the coefficient of y. I have only y. What is the derivative of y? 1. So 4x squared. Okay, or if you want to put 1 kasih. All right, because the derivative of y is 1. Okay, now once you understand the rule, you don't have to do like what I'm doing now. But of course, if you want to continue doing, that's good. You can do it right away from here. Okay, so if you do it right away, so you just write fx equal to what? Fx equal to x cubed. So x cubed 3x squared. Now you know the y is a constant, all right? So you know y is a constant. So what you can do, you just do it right away. So I got 4, okay, multiplied by 2x, all right, 2x. And then y, okay? Y is a constant, just follow through. So you don't have to rearrange. You can do it right away, okay? And then for the fy, you got x squared, which is a constant. Ini senang sebab the x squared is 4x squared. And then the y is a constant plus 12y. Okay? What I'm saying here is this. After you understand the concept, you don't have to put the constants together like what I'm doing. You just do it right away from the top, okay? Without rearranging. Okay, all right. Now, I would like you to look at another example which they apply a different rule. Look at the example which they apply the power rule. So look at example number 4. Example 4 in the book, where you have the power rule. Okay, so I have z equal to what? Equal to x squared minus y squared to the power of 2. Banyak sangat 2. Okay, tak apa. We follow. So now you apply the power rule. Okay, the power rule. Visual power rule. What is the power rule? So you go back to the y-x. So you go what? Y prime is equal to what? You have u to the power of n. So no, u to the power of n. That's the function. Now what is the rule? The derivative is y. You reduce the power. You bring the power n. Okay. And then you multiply by u. Reduce the power by 1. And then you take the derivative, or you take u prime. Okay, so now what you need to do here, you take that u prime. And of course, the u prime is x squared plus y squared. So that is the rule. That rule apply. Okay, So what you do here for the partial derivative, all right, imagine that it's u. So I let u be equal to what? Be equal to x squared minus y squared. That is the terms in the bracket. Okay. Now, what we want to find first is fx, the derivative of the function with respect to x. All right. So you apply that rule. Okay. So I have what? I have here u to the power of 2. Okay. Because you have the variable x in that thing. So when you have u to the power of 2, that will be equal to what? Equal to u, 2 multiplied by u to the power of 1. Okay, I put bracket, huh? And then what do I need? I need the derivative u prime. Now, when you put u prime, sometimes you think of u prime here, dy dx. But now, okay, you don't talk about dy dx. I'm talking about dz dx. Okay, du, I'm sorry, du dx. Okay, du dx. Du dx. So du dx, what you can do, you can write u prime pun boleh tak? Okay, but make sure you know that u prime is du dx. So sini ni you can write du dx senang sikit itu. Du dx. Okay. So the only thing that you need to do here is you have to find du dx. Oh, I already let u be equal to x squared, y squared. Or you can write this, you know. You can write this du dx. You can write, I write down here 2u to the power of 1 multiplied by, okay, u prime du dx. So you can put ux, just macam fx. Now you know that I have to take the derivative of u with respect to x. Okay, so I have already u too. So what is du dx? Du dx or u, apa dah? What is it? Take the derivative of that terms, of that function, x squared minus y squared with respect to x. What do I get? Okay, somebody, back. Apa?
2x.
X. 2x itu senang, eh? Because it's just additive. All right? The y squared is a constant, so 2x. So therefore, fx, or you can put that x pun boleh juga. Okay, is equal to 2 multiplied by u. So now you can put back the u, which is x squared minus y squared. That is everything. The power of 1. Okay, multiplied by du dx, which is 2x. So I put 2x. So the power rule, okay, you have to get back to the basic power rule. That's the basic power rule. All right, but when you apply to the partial derivative, you have to relate back. Okay, relate back. Which partial are we talking about? Okay, so in this case here, the u prime is du dx because we're talking about what? We're talking about the partial derivative with respect to x. Okay, all right. Any question? So now you take fy. Okay, so when you do the derivative with respect to y, then that u prime is not du dx. It's now what? Du dy. Because it's derivative with respect to y. Okay? So if I take derivative with respect to y, fy, they apply, the power rule still apply. So that becomes what? That becomes n u to the power of n minus 1. Now you multiply by u prime. But now u prime is du dy. So in order for us to not be confused, I can write ux. Or I can write du dy. Okay? Kalau you put u prime, nanti we take derivative with respect to x. But here you are talking about derivative with respect to y. Okay? I already have everything will be rule are the same. So you let u be equal to x squared minus y squared. So what is u? I'm sorry, not x. U. Uy. So uy, derivative of u with respect to y, or du dy. What is it? The x squared to constant. Okay, 0. So there will be negative 2y. So therefore, our partial derivative, you apply the rule, fy is equal to n. All right, n, and then I got u, okay? So I put the u right away back, x squared minus y squared, of n minus 1, so that is 1, okay? Multiplied by u of uy, or du dy, that is negative 2y, okay? Ataupun, okay, I think we go step by step. So let us start from the beginning. So now, okay, now from there, I write down the function, okay, the function in terms of u. So I got that equal to f of xy equal to u to the power of 2. All right. So the derivative fy, I got u of 2 multiplied by u to the power of 1. You don't have to write 1 because it's just 1. Multiplied by uy, or du dy. So I write another one, but you don't have to, okay? It's just to make sure, or you can choose du dy. If you write du dy, okay, because you can see it clearly, okay? So du dy. So now we substitute everything. So I got that do u prime, I'm sorry. U to the power of 1. U to the power of 1. Okay, u. So u is, what is u? U is x squared minus y squared, power 1. And then du dy, negative 2y. All right. So if you want to avoid some confusion, you can start here. But once we know that the u is the thing that we put there, then right away do that one. Okay. Put right away the u. All right. Okay. So that is the power rule. So next period, I want to establish the quotient rule. Okay, the quotient rule. Sometimes the quotient rule, it's not difficult, but it's tedious. Okay, it involves more work because you have to divide. All right. So we are going to discuss how you apply the rule. So I'll give you some homework question 14.2. Over the weekend, you have to practice. Okay, you have to do a lot of practice if you are not sure about this. So I want you to do everything from question 1 up to question, kita boleh hentam je sampai berapa, tak apa dah. Alright, question 19. Okay, question 19. Alright, question 19, lepas tu, tak ada lah, nanti buat. Okay, ada lagi. You can do 35. Okay, 1 to 19, ada quotient rule. Okay, you do everything Quotient rule tak payah lah. Okay, quotient rule tak payah. Because we haven't learned yet. Okay, quotient rule tu tak payah buat dulu. If you want to try, you can try, but you don't have to. And then if there are terms in X or question in log, tak payah buat juga. Okay. And then if they ask you any other things, you don't worry. You just do what? Fx, Fy. You know, don't follow the question. You just look at the function, just find the partial derivative. All right? Okay. All right. All right, good. Now, I observe at the beginning of the class, there are only about 30 people today. All right, about 30 people at the beginning. So there are 30 more plus people. So these 30 plus people, I want you to check with your friends, okay? Because I discussed about the midterm at the beginning. So I'm not going to explain one more time. Okay. The midterm, I already talked about at the beginning of the class. If you miss the beginning of the class, so don't ask me about the midterm, you check with your friends, all right? We already discussed about the midterm. I give you the time, I give you day, I give you already everything, okay? Don't ask me anymore, ask your friend, because I already discussed. Okay, all right. Anything else? Okay, all right. So I will see you again next week. I want you to start study now, okay? Don't wait until next week. Don't wait until 2 weeks from today. You start study now. The reason I give you more time, because I want you to spend more time doing the practice, doing the question. Okay? So if you want to follow what I said, it's okay. Okay, you can wait last minute. Bagus tak? Okay, buat last minute. But my advice, okay, my advice to you, if you want to follow, you start doing it from now. Okay, do the questions, do the homework questions, do the practice, review the notes. Do it now. Okay, at least from this week, so that you have ample time, so that you can do better in the midterm. Okay, so discuss. You have a problem, discuss with your friends. If you have a problem, you can discuss with me. Okay, you can put the question in the WhatsApp group. Okay, any question, you don't WhatsApp personal to my number. Okay, we share. Okay, we share with other people. So put in the group. If you think that your question is stupid question, very simple question, don't worry. It's not only you who have that problem. At least there is another person who have the same problem, but they don't want to ask. So you are the one to ask. So don't be worried about my question is too simple, you know. Question in apa bodoh. Don't worry about that. Okay, if you have a problem, you ask. Don't worry about other people. Other people, they don't ask. Don't worry about them. You worry about you. Okay, you ask. Okay, even though the question seems to be simple, but sometimes this simple thing, if you miss, that can add up. Okay, that can add up to the more difficult one. Okay, all right. I'll see you again. Have a nice weekend. Assalamualaikum warahmatullahi wabarakatuh.
Yes, sir.
Okay, sir.
Thank you, sir.
Thank you, sir.
Thank you,
Okay,
sir.
thank you.
Thank you, sir.